Hello, my name is Tristan Kelson, and this is my first problem, which is analyzing a Yeti cooler. Here we are asked to determine the heat loss, for which we know we will need to provide a resistance network, as shown below. This takes into consideration the different layers of the cooler, which were also found and referenced from the Yeti website. Here, in order to do this, we need to take the area of each of the shells of the cooler. It is important to take into consideration the effective area in order to get the accurate areas, which can be seen below. Here we then provide and calculate our convection and our conduction equations, as seen here. However, for the first R convection on the outside, we are not given H. Here we use methods for solving H for external forced convection in order to solve for the H value of 51.51. Here we are then able to plug this value back into R convection 1 in order to get the proper value. Also, including radiation, we were able to solve for H radiation by the following equation, as learned in class. After this, R, resistance of radiation, can be treated as R convection, which can be seen here in order to calculate the resistance due to radiation. As we know, we will need to calculate the total resistance, which can be seen in this calculation. Here it was determined to be 6.1874 Kelvin per watt. From there, we can solve for Q by using the following equation, and solving, we get a value of 11.31 watts. In regards to feedback from this problem by Gray Patterson, initially when solving this problem, I had forgotten to include this front side and the back side. Here she was able to help me, and I was able to include these sides in the area as shown below. Hello, in the next problem we are going to be analyzing the temperature changes of a meat carcass using transient heat transfer equations. Here we are given the initial temperature of the beef along with the temperature of the flowing air, cool air, and given the dimensions of the sphere. Here we will be treating the carcass as a sphere. We are given the H value, and we are asked how long it takes for the meat carcass to reach a temperature of 0 degrees Celsius. First, we must calculate the BO number, in which we were able to get it to be 9.525. Next, from table 4.2, we were able to interpolate to determine the values of lambda and A1. Using the equation for single-term transient heat transfer, we were able to determine tau to be 0.4. Now, because tau is greater than 0.2, we know that a one-term solution is okay. Using the equation for tau, we can then calculate the time. The time it takes for this beef carcass to make it to 0 degrees Celsius with air flowing at -10 degrees Celsius at 2 meters per second is 21.5 hours. Here when it came to discussion with my partner, there was no discussion to be had as she also agreed with my answer and thought it to be correct and make sense for the following situation.